Back. All right, hi everybody. Just throwing this video clip together to review some of the things that we know really well about the atom, and then I want to introduce or emphasize a few things that I've only glossed over in class, but are very important for you to know moving forward. So jumping right into it, you are all familiar with the simple model of how an atom is structured. You know about the center part, which is called the nucleus, and then you know about the parts that orbit around, which we'll talk about in a second. So this is an example of an oxygen 16 atom, and I'll talk about what that 16 means in a moment if you don't already know. But let's focus first on one of the parts of the nucleus, which is the protons, and they have a positive charge. They're represented red here. The proton number can be determined by looking on the periodic table, which you all have, and looking for that number that's in the top left corner. So how many protons does hydrogen have? Hydrogen has 1 proton. How many protons in the nucleus of a helium atom? 2. The other part of the nucleus, as I'm sure you know, this is a review, are the neutrons, and they are neutral. So please don't be thrown off by the N beginning letter. It doesn't mean that they're negative. They are neutral. They carry no charge. And coming back to the name of this atom, so this atom is an oxygen 16 atom. This means that if you count the red circles, and you don't actually have to, you could just take my word for it, there are 8 protons, 8 positive protons, and there are also 8 neutrons. So the number that follows the name of the element represents the mass number. So in this case, we have 8 protons, we have 8 neutrons, add them together, it equals 16. You may remember we've drawn some pictures of, we referenced a little while ago, something called isotopes. And isotopes are atoms of the same element that have a different number of neutrons. So again, if we take that dash number, right, so we have the name of the element, which is determined by the proton number. All oxygen atoms must have 8 protons. I'll go back and show you the periodic table again to prove it. 8 protons. Okay, great. But the number of neutrons may vary. Some atoms of oxygen may have more neutrons, some may have fewer. In this case, this oxygen atom, right, simple math, 8 plus 8 is 16. The mass number is 16, so this has 8 protons and 8 neutrons in the nucleus. Oxygen 17, however, still must have 8 protons. All oxygen atoms have 8 protons, but the neutron number is different. A neutron number must be 9 if the mass number is 17. So that might be a question that you see in an assessment. We're talking about a partner quiz coming up this week. So please make sure that you know the difference, or you know how to determine the mass number of an element. So here's a quick practice question for you. You can pause or use your periodic table. I might even make this a follow-up question after you watch the video. If you have carbon 12, what is it that makes this atom different than carbon 14? So is it the proton number that's going to be different, or is it the neutron number that's going to be the different value? And what could these two values be? So a little bit of a practice question there, if you could. Okay, here's a part that I definitely want to focus on because I've only alluded to this in class, and I want to give some attention to this. You might be asked to make an electron arrangement for an element. We've talked about where the electrons are. They orbit the nucleus. We've talked about how the electron number is always the same number as the amount of protons. So for example, for beryllium, beryllium's atomic number is 4. It has 4 protons, and it also has 4 negative electrons. Those two particles cancel each other out in terms of their charge. So coming back to here, the negative electrons are represented by the green circles here. And the electrons don't orbit in the same one cloud or the same one ring. There are several clouds. And we learned a simple formula that helps us determine how many electrons can fit inside of each cloud. So hopefully you remember a little while ago, I think maybe sometime last week, I introduced you to the formula of 2n squared. And the letter n represents what number shell, what number cloud you're referring to when you are trying to figure out how many electrons fit into each cloud outside of the nucleus, right? So the very first shell, the shell that's closest to the nucleus, the first electron cloud can only hold 2 electrons. So if n equals 1, n squared is 1 times 2, right? The second shell can hold up to 8 electrons. It can't hold more than 8. So if you have an element that has more than 10 total electrons, it will spill over into the third shell. And we'll do some examples of making electron arrangements so that this makes sense. But as long as you know up to 3, I don't think I'm going to ask you to do anything more than 3 shells. You should be perfectly fine. So here's a sample question. We'll do 3 sample questions of the kind you might see on an assessment or a partner quiz or something like that. So let's say the question asks you, show the electron arrangement for, and I ask you for a specific element, right? Now you know how to use the periodic table. You don't have to memorize this. If I ask you to show the electron arrangement for beryllium, I'm asking for you to look to the atomic number and find out how many protons or how many electrons exist in that atom. Okay, so in this case, beryllium has 4 electrons. So what you would provide for me, what you would draw for me, and I would say, don't worry about the nucleus. You could just put the chemical symbol of the element in the nucleus. So we want to draw almost like a bullseye. We want to show the target where the electrons would fit. Okay, so here's beryllium, and I've drawn the first shell outside of the beryllium nucleus. I've drawn the first cloud, right? So how many electrons can fit into the first cloud? Can it hold 4? It can't hold 4. If you remember our table, the first shell can only hold 2. So I'm going to take my first 2 electrons and I will position them on in the first ring. You don't have to draw all sorts of dots on an actual quiz. If you want to use the shorthand, if you want to write 2e negative, that would be perfectly acceptable. So we've represented 2 electrons, but we're still missing 2. The first shell cannot hold more than the 2 electrons that it currently has. So what you have to do now, you must draw a second ring. And I said those extra electrons spill over. So in this case, for 4 total electrons, my remaining 2 need to go to this second shell. So I have 2 electrons in the first shell of beryllium, 2 electrons in the second shell of beryllium. And of course, you probably remember, we've been working on using the term valence electrons. Valence electrons mean how many electrons are in the outsidemost ring. So beryllium does not have 4 valence electrons. It doesn't have 4 outermost electrons. It only has 2 outermost electrons. So important to note when you're talking about valence. There's a pattern that maybe you've noticed or you've heard me talk about. Beryllium is in the second tall group. Remember, groups are columns. Groups go up and down. When I refer to tall groups, I'm talking about the ones that are not transition metals and the groups that are not the rare earth elements. I'm talking about group 1, 2, group 13 is tall, 14 is tall, 15, 16, 17, 18, right? Get the idea? So since beryllium is in group 2, we could make the assumption that it has 2 valence electrons, and that's completely true. Every element in this group, strontium, barium, radium, they all have 2 valence electrons. Here's another trick. The number of shells, the number of clouds that the atom will have, if you do electron arrangement, that always matches, that always corresponds with the period. Period goes left to right, like the end of a sentence. The first period elements only hold 1 shell. They only have 1 electron cloud. The second period elements, all of these have 2 clouds, 2 electron shells. The third elements have 3, 4, all the way down to 7. There is no element that will have more than 7 electron clouds or electron shells. Okay, so we got the first idea. Let's try another one. We'll do 2 more. Show the electron arrangement for sodium. Okay, so remember, if I'm asking for your electron number, you want to find the number of protons, which is the same as the number of electrons. You're looking for the atomic number right there in the corner, so 11. We can work backwards now if we want a little help in making our electron arrangement. So I can look to my periodic table to help me find sodium. There it is, element 11. I can see that it's in the first group, which means I'm assuming that it has 1 valence electron. We'll verify that. We'll see if that's true. And it's in the third period. So it should have 3 electron shells. In my drawing, I want to verify to see if this rule is in effect, if it actually does help me with my electron arrangement. So here's what you would draw on your piece of paper if you had a partner quiz or something like that. Draw the symbol in the middle. You don't have to draw all the protons and neutrons, not necessary. Here's the chemical symbol. I'm assuming that it has 3 shells because I looked at the period number. I'm also assuming that it has 1 valence electron. Let's see if that's true. So I'm going to place the 1 valence electron out here, right? I know that it's in group 1. I know that the inner shell can hold up to 2 valence electrons. I've drawn 3 out of a total of 11. I'm missing 8. But if you remember the table that we looked at back here, my second shell can hold 8 electrons. Let's see if this math works out. So my completed electron arrangement, something you would provide for me, two in the center, 8 electrons fit in the second shell, and 1 valence electron is in the outside. This would be a complete electron arrangement, and it does add up to 11. So this would be completely accurate. If you want to just write the number with the letter E, that's fine. You don't have to draw all these dots, okay? One more very quick one, because I know this is getting a little long. Argon. Let's say you had to draw argon, right? Electron arrangement, element 18. Look at your periodic table. Argon, over here, it's a noble gas. It's in group 18. It will have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons according to my rule, and it will have 1, 2, 3 shells or clouds. Let's see if it's true. I've drawn the chemical symbol, 3 shells. I'm assuming 8 valence electrons. Let's see if we can properly draw 18 electrons on our chart here. And I made a little typo. This is supposed to be AR. Excuse me. AR. Perfect. 2 in the first shell, 8 in the outside shell. I am missing 8. My sum should be 18. But if you remember, my middle shell, my middle ring, my second ring can hold 8 valence electrons. So the correct answer, the proper way to represent argon's electron arrangement, 2 in the first shell, 8 in the second shell, 8 in the third shell. Thank you for watching. I hope this helps with your questions and your quiz later this week.